Students, we are given this question. Show that 2 positive I times root 3 raised to the power 10 positive 2 negative I times root 3 raised to the power 10 is real. Now, you have to know, to show that any complex number is real, we got to show that it is equal to its conjugate. So how is that done? So foremost, let me take z to be as 2 positive I times root 3 raised to the power 10 positive 2 negative I times root 3 raised to the power 10. Okay, now to show that z is real, we need to show that z equals to its own conjugate, z bar. So this is the necessary condition. So for that, let us consider now z bar, which is equal to 2 positive I times root 3 raised to the power 10 positive 2 negative I times root 3 raised to the power 10. So this has to be placed under the bar. So that means you're taking the conjugate. Now we know that a very important result. Conjugate of the sum is equal to sum of the conjugates. We know this. Okay. Because of this property, this is going to be rewritten as 2 positive I times root 3 raised to the power 10 conjugate positive 2 negative I times root 3 raised to the power 10 conjugate. So we can have this. Now we also know that z raised or z having its conjugate, and that it has some quantity as its exponent. So conjugate of an exponential quantity like this can be rewritten as the conjugate being brought inside and then raised to the exponential quantity. So this is a very important result. Okay, now because of this result, the conjugate and the exponent can be interchanged. So that would mean we will now have 2 positive I times root 3. Okay, so we are bringing the conjugate of it. So that's conjugate, and that is being raised to the power of the exponent. Similarly, the conjugate is brought in 2 negative I times root 3. You bring in the conjugate inside and then raise it to the power of the exponent, which is 10. Now when we do that, conjugate of this is going to be 2 negative I times root 3. That has to be raised to the power of the exponent positive. Conjugate of this is going to be 2 positive I times root 3 raised to the power of the exponent 10. Now what is this? This is exactly what we started with, right? Let z be this quantity. So this is actually equal to z. But what's the point in which we considered z bar? So on the left we got z bar. So this would imply, since z is equal to its conjugate, this implies that z is real. So that completes the proof for this particular question.